Okay, so I kind of just copy pasted this information here. I'll close that. This is the maximum depth of binary tree question. Yep, so copy pasted the question. I just wrote this out. I removed kind of this code and challenged myself to try and write the tree node class. Same thing here. I tried to write like this max depth function myself. The reason why I do this is because I usually practice in Swift, like for my iOS development work. So I don't have oh, it's thundering. Not sure if you heard that in the recording, but okay. In Python, we have to do a lot of this like self stuff, and to be frankly honest, I forget to do that. So just to get into the habit of things and assume worst case, I've given nothing. I just want to make sure I can at least write this boilerplate stuff, because this, yeah, it can really keep you stuck if not. But so here's the question. So given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path. Along the longest path from the root node down to the farthest leaf node. So we are given an example there, but I'll do another example. Why not? And I'm pretty sure binary tree just means that every node has at most 2 nodes, or is it? Doesn't mean every node has to have 2 nodes, because I know in binary tree then there's like nearly complete binary tree, complete binary tree. Like there's different types as well. So I think this is a valid binary tree, like this one right here. And maybe I feel like this is a valid binary tree. And then the longest length here would be 1, 2, 3. It'd be 3 would be the longest. 1, 2, 3. Yeah, I'm pretty sure 3 would be the answer here. Just to confirm. Maybe I should search up binary tree definition. Just in case. I don't want to be doing this in the wrong way. Yeah, it has at most 2 children. Geeks for geeks, will you save the day? Yeah, it has at most 2 children. Cool. Alright. And then just to make sure I got the definition of height, 1, 2, output 3. Okay, I'm doing something wrong. So 1, 2, 3, 4. Hold on, did I read another test correctly? It's the number of nodes. Good. So that would have been a bad thing because I didn't read the definition properly, and I didn't remember what depth was. So it's not 3. It's 1, 2, 3, 4. 4. All right, we're learning life lessons here. Now, that was one example. I guess kind of thinking about constraints now, can this be like an empty tree? Is a root actually needed here? It's optional, so I'm assuming it could be none as well. In that case, the maximum depth would just be 0. If there is just the root, the maximum depth there is just 1, because that's just one node. And so on and so forth. And if it's the same, right, if both the left and right subtree have the same height, then there's, then it doesn't really matter. But what I'm seeing right now is that you do, well, actually before like thinking about like how I would try and solve this, let's continue asking some clarifying questions. So we have val here, left, right. You can have like a left subtree, but you don't necessarily need a right subtree, and vice versa. You have to return an integer, and that integer is the maximum depth. Okay. Yeah, so I think I asked all the clarifying questions, like can this be empty? Well, I can ask how large it can be. What else? Yeah, different conditions, like if they're the same height, if there's no left subtree, if there's no right subtree. I don't think there's really much else to ask other than that. Maybe the actual values in the nodes, which I just saw, but that's not really relevant to the question, to be honest. Yeah, I don't know what this information will help us do, so I don't know why it's, yeah. Okay, so it's from 0 to 10 to the power of 4. Cool. So I mean, immediately I see like depth, return depth, or maybe like just results. And if not, return res. Not just a 0 to be very explicit. And then you gotta just code something out here to do. Now in doing this by hand, the way I see it is because I just, you know, as a human, I just see the longest path naturally. But obviously, like if this was a convoluted binary tree and there's a lot of kind of nodes, sometimes it's hard to kind of tell. So I just kind of go down every single path, like all the way down to the leaf. So 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. And you know, after counting all those like all the nodes in the different paths, I determined that this path is the longest. Now, this is like an O of n algorithm where n is the number of nodes. Is there a way for me to determine by default that this path over here is the longest? Like, because then I can reduce it to log of n time, right? Because then I don't have to traverse down each of these paths. And the answer is, I don't think so. Yeah, I don't think so. Because then, like, how would you determine that this height is, like, how would you know the height of this path if you don't go down it? Like, would I just, like, this seems like a maximum question where, like, you go down every path and you have to, like, just determine, like, keep track of which path was the maximum. Or not exactly which path, but just, like, what the maximum depth was of that path. And then you go down, this was 3, and then when you go down this path, you see it's 4, so you replace the 3 with the 4. I just don't know if that's the ideal time complexity. It's O of n. No space complexity, constant space complexity. I'm pretty. Oh well, I guess since we'll be recursing down this path, there is some added time complexity because of recursion. I forget what that time complexity is. Let me go with this like the solution because it's really the only one I can think of. I can't think of a more optimal solution for this. So let's see. Alrighty, so to do. So we want to go down. Well, we know we can do rest plus equals 1. And then we could do something like this, where we do right dot left and root dot right, and then return res. I feel like that should work. Well, let's see. So we start at res. Before even running the code, I just want to like run it by hand myself. So if not root, then we return 0. But here, there is a root. We add 1. So 1 is currently what res is equal to. And we go down the left subtree, right? We come down here. It's not none. Res is equal to 1. Maybe actually, to avoid confusion, because this is the res on the main, like the first kind of call, and then res 1 is the call on this subtree. Okay, so when you do 1, then you call this again, then you call over here. Root is not none, so it doesn't return 0, but it does know res is equal to 1. So res is equal to 1. Okay, then it tries calling max on this, but we can see that this node here has no left subtree, so it will return 0. And same thing with the right, no right subtree, so it returns 0. So return res, so it returns 1 over here for left subtree. So now that's equal to 2. No right subtree, so that's going to be equal to 0. So now 2 is passed over here. And I'm not keeping track of the maximum. That's a problem. So it should actually be max of the 2. Man, going through by hand is such a wonderful thing, because I come here 2, right? And then this is 2, and then you add 2 and you make res equal to 3. But before that, you'd have to like determine the right value as well. And you kind of go down the path. One path is gonna be 4. The other path is like, I mean, there's also this conflict here of the 2 different paths here. But you'll notice quickly that this path is gonna be 2. This path is gonna be 1, or yeah, and then this path is gonna win, and then it'll keep on going up, and then it'll eventually get to 4. Now, okay, so let's try running this. Let's see. Oh jeez, what did I do wrong? Max step is not defined. Solution.maxstep. Solution.maxstep. Missing 1. Means self. Why is this syntax so weird? Okay, I gotta learn some Python syntax here. Like, how can I clean this up? I'll probably put that into ChatGPT and see. So these 2 cases, and then if I submit it, okay, nice. Nice. 0 milliseconds beats 100%. Oh, jeez. 54% of solutions use 0 milliseconds. Oh, now we don't feel special. Alright, that was a quick video. That was a quick solution. So I'll leave it at that. Might watch a new code video, see if they have a better one. Alright, yeah, see you.